Hello friends, my name is Lalit Singh Mehta and today I am going to solve a numerical based on the topic stresses in composite structures of equal lengths. So this is the question which we are having with us. A composite bar. Composite means a mixture of two or more materials. So it is made up of a brass rod of 25 dia enclosed in a steel tube of 40 external dia and 30 internal dia. So this is the figure. There is a steel tube and inside that steel tube the brass rod is being placed, which is clear from the diagram from the question, and the dimensions of the rods, the external diameter, the internal diameter of the steel tube as well as the diameter of the brass rod is given. Then the rod and the tube are coaxial, the axis for both the material is same and equal in length for both the materials are equal, are securely fixed at each ends are fixed. If the stresses in brass and steel, stress value of the respective materials are given as 70 and 120, and find the load P the composite bar can safely carry. This P, the load which this composite material can safely carry, is to be found, and also find the change in length of the bar. We have to find the change in length of the bar due to this P, due to this load P. So first we have to find this P and then we have to find the change in length of this whole material or composite material. The Young's modulus of elasticity for the steel tube and brass rod is given as 200 GPa for steel and 80 for brass. So let us start with the problem. This is the given diagram. This is the front view, this is the cross sectional view with the diameters. So first, for this type of problem we have to start with the given thing. First let us write down all the given things. So I will use some denotions for it. Composite bar is made up of a brass rod. So let brass rod of 25 dia. So brass rod can be given as dB, which is 25 correct? Then next thing is enclosed steel tube. The dimensions of the steel tube are given, the external and as well as the internal diameter. So external diameter capital DS, which is 40 and internal diameter DS, which is equal to 30 That's why there is a gap here, because the external is 40, the internal is 30, and inside that 30 there is a 25 brass rod. So that's why some gap is being placed, is being shown. So this is the things. Then lengths are given, length of the tube, but lengths are equal. Therefore I will write length which is equal to length of brass rod, which is equal to length of steel tube, is equal to 500 This is the given thing from the diagram. Then stress value is given, stress in brass and steel. So stress in brass can be written as sigma B, which is given as 70 megapascal, and which is same as Newton per square, and stress value in steel is given as 120 megapascal, which is again same as Newton per square, correct? So anything which I have missed? And Young's modulus of elasticity, E for steel is given as 200 GPa gigapascal, which can be converted to 200 into 10 raised to 3 Newton per square or MPa, both are same. And E for brass is given as 80 GPa, which is nothing but 80 into 10 raised to 3 Newton per square or MPa. So these are all the given data from the given thing. We can list it here. We have listed here given things. So this is all the diagram. So what we have to find? We have to find first this P, the load the composite material can carry And second thing is find the change in length, delta L of composite bar, or you can say composite material. Find the change in length of this bar. Now solution. So if you have seen my earlier video, I have already explained the means derivation, or we can say the formulation for solving stresses in composite structures of equal lengths. So we will directly go into that. You can check my earlier video for it. So whenever there is a composite structure of equal length, then the total load P, which we have to find, this is the same P. The total load P is equal to, since there are two materials, the steel tube, this load, total load is being shared by two materials, steel and brass. So I can write it as P1 and P2. Similarly, if more number of materials are there, then the P3 plus Pn. Correct? These are all the loads. Load carried by material 1, load carried by material 2, load carried by material 3. It will go on, since it is a composite material. So minimum requirement is 2. So in our case, this will be P of steel plus P of brass. Correct? This total load P is carried by two materials, steel and brass. Now we know that stress is given by load upon area. This is a simple basic formulation, stress. So therefore this can be written as P is equal to sigma into A. Correct? Load is equal to stress into area from here. So instead of PS and PB, means load carried by steel tube and load carried by brass rod, I can put this value. Now it can be P is equal to, instead of PS, I can write it as sigma S into AS plus sigma B into AB. So this is our first relation which we get. Correct? So this is the first relation which we can derive for a composite structure of equal length. Total load is being shared by two materials, since there are two materials, so steel and brass, but steel and brass can be written as sigma A. So it comes like this. Now what we have to do is, now the next question comes is, the sigma S is given, sigma B value is given, sigma B, sigma S. But we have to cross check this value of sigma S and sigma B. We cannot take the values as it is. Being a design engineer, we have to always cross check the values. Means this 70 megapascal and 120 megapascal is the stress in brass and steel, which I have to cross check before putting it here. So I have to just change this. So let us first see. Now for cross checking sigma S and sigma B, whether this value are correct or not, as we know the lengths are equal, we can see the lengths are equal. Correct? Lengths are equal. This is the given thing. You can see if the composite bar is 500 mm long, composite bar is 500 mm long, for steel tube and for brass rod it is 500 mm. Lengths are equal. So it means that strain will be equal. Correct? Strain in both the material will be equal. Strain in material 1, strain in material 2. Since lengths are equal, therefore strain in both the materials will be equal. Correct? So in our terms there are two materials, so E in strain in steel tube is equal to strain in brass rod. I can write like this. Now we know that E is equal to sigma by small e, therefore E is equal to sigma by capital E. This is from Hooke's law. So I can put, instead of strain in steel tube, I can write it like this: sigma of steel upon Young's modulus of elasticity of steel tube is equal to sigma of brass upon Young's modulus of elasticity of brass rod. So this is our second relation, I can say. First relation is this, second relation we got from sin lengths are equal. So these two are the relation which we got. Now moving further, we can see this we have got from here, sigma S upon ES is equal to sigma B upon EB, correct? This we have got from ES is equal to EB. Now I have to cross check whether the value of this 70 and 120 MPa which is given to us is correct or not. I have to cross check. So I will take case 1. So I can write this equation as sigma S is equal to ES upon EB into sigma B, correct? I can write this equation like this, and also I can write this equation like this: sigma B is equal to EB upon ES into sigma S, correct? Like this I can write these two equations. This equation can be written like this, and the same equation can be written like this also. First I am taking sigma, finding the sigma S value. Second I am finding the sigma B value, I can say. Sigma B, EB, ES, sigma S, correct? Now here we can see sigma S. So sigma S is equal to Young's modulus of elasticity of steel value is already given to us, 200 GPa, means 200 into 10 raised to 3. 200 into 10 raised to 3. EB value is also given, 80. 80 into 10 raised to 3 into sigma B. Sigma B, suppose we put, for cross checking, we put the sigma B value, stresses in steel, 70 MPa, 70. So we will get the value of steel. Similarly, this value of steel is coming out to be 175. 175 Newton per mm square, correct? This is case 1. So for the case 1 I got sigma S. When I put sigma B is equal to 70, sigma S is coming out to be 175. And in the second case, sigma B, if we put EB is, or again EB is 80 into 10 raised to 3, ES 200 into 10 raised to 3, sigma S, so sigma S value which is already given to us, 120. So the value of sigma B is coming out to be 48 Newton per mm square. I will cross check it, correct, 48 mm square. So this is case 1, so and this is case 2, correct? Case 1, we have, what we have done, we have applied the basic rule of design which says that we have to cross check. So I am cross checking the value of sigma S when I put sigma B as 70 and all the Young's modulus value which is given to us. So I get 175, and when I put sigma S value 120, I get sigma B is equal to 48. Now you can see in the given thing, in the given problem, sigma S is given out to be 120, correct? And sigma B in the given problem is given out to be 70 MPa or Newton per mm square. Both are same. Correct? Now, this is given. This is also given. Now what we have done, in the case 1 we have cross checked the sigma s value. So this is 175 which is more than 120. So this value of sigma s is equal to 175 MPa is not safe. Why it is not safe? Because it is more than 120 MPa which is given to us. So this value of sigma s is not safe. Why? Because this value is exceeding the given value of sigma s. And this value of sigma b, which is 48 MPa, is less than 70 MPa. So it means this value is safe. Why it is safe? Because it is less than the given value 70 MPa. So in this problem, so this is not safe, this value is not safe, and this value of sigma b is safe. So case 1 proves to be not safe, and case 2 proves to be safe because we have cross checked the values. Now, so our new values of sigma s and sigma b will be, what will be our new values? Since we cannot accept this value, so since this is not safe, so we have to go with this value. So when sigma of steel is 120, correct? When sigma of steel is 120, sigma of brass is coming out to be 48. So this will be our new values. Why I have chosen this 120 and 48? The reason is very much clear. Because this case, when we put sigma b as 70, sigma s is coming out to be 175, which is more than the given value. So this is unsafe. We have crossed it. This we cannot select. But in the case 2, when we put sigma s as 120, sigma b is coming out to be 48, which is lower than the given value. So this is safe. So my new values are 120 and 48, which I have taken here, 120 and 48. Now we have to proceed with the problem taking this new values. Means we have made our design safe. Now we can proceed with this two new values. Forget the earlier values. Earlier value was sigma s is equal to 120. This is correct, and sigma b was 70. So with this 70, which we have to omit. Why we have to omit? This is the reason. Since we have cross-checked both the cases from the design. Now, proceeding further, we already know, we have already derived this equation 1. So instead of sigma s and sigma b, I can put the new values which I have found. Sigma s will be 120 and sigma b will be 48. So these two values I have to put in place of sigma s and sigma b. Area steel and area of brass rod can easily be calculated. So this total load P which is equal to sigma SAS plus sigma BAB is equal to sigma S value, new value of sigma S 120, area will be pi by 4 since it is a tube, so ds square minus ds square bracket close, this area of steel, plus sigma B will be 48, area of brass is pi by 4 into dB square. So by solving this, all these values we can put ds, all these values are given. So P is coming out to be 89.57 kilonewton, or I can say 89.57 into 10 raised to 3 Newton. So this is our total load. The total load is 89.57 which we have got. So this is the load which this is the load which the composite bar can actually carry. Done. Now we have to find the change in length, delta L we have to find, correct, for the composite bar. Now we all know that delta L is equal to PL upon AE, correct? This is by Hooke's law. So either I can apply delta L is equal to P of steel, L of steel upon A of steel upon E of steel. So I will get one value since load on steel. Now I know the load on steel, this value, this PS is equal to this sigma SAS, and this PB is equal to sigma B into AB. So by solving this, since we know the value of steel and area of steel tube is also known, sigma B AB, we will get this value. So if we put this value here, PS value and LS, it is common for all since length was equal 500 mm. Area of steel tube, again it is, you can find out, E of steel, Young's modulus of elasticity, everything is given. So the value is coming out to be 0.3 mm. Similarly I can find delta L is equal to PB LB upon AB EB. This value will also be 0.3 mm. You can cross check it. PB will be sigma B into AB, LB 500 mm again, AB pi by 4 diameter of brass square, Young's modulus of elasticity of the brass metal is given, so 0.3. So both these values are same. You can see both these values will be same. Why they are same? Because the composite material is fixed together, securely fixed together, and the lengths are equal. That's why this value are coming out to be same. So this is how we have to solve this problem. Again I will revise once again if you want. So this was the actual problem. You can see this was the actual problem. All the given parts I have written. Since it is the problem of equal length, therefore length was taken as equal. Length of brass is equal to length of steel. Every denotation, Young's modulus value is given, sigma is given. Then we have to find load the composite material can carry. This I have to find. So I have written first, then delta L of the composite bar, how much it will extend I have to find for this material. Now we can see the total load on a composite bar is given by P1 plus P2 plus P3. These are all the loads of the respective material. So here load on material 1, load on material 2, load on material 3, that's just n number of material. So in this case we were having steel and brass. So steel, load on steel plus load on brass. But P is equal to sigma A, simple relation. So instead of P I have put this value here. So sigma S AS plus sigma B AB, correct? This is equation number 1. Now since lengths are equal, therefore E1 will be equal to E2. Since strain are equal, Therefore, strain of material 1 is equal to strain of material 2. So in our case, it will be strain on steel will be equal to strain of brass. Therefore, strain can be written as sigma by E. Therefore, I have replaced this value with this value. So this is equation number 2. Now, after this, I have to cross check the values of sigma S and sigma B. So what I have done here, see, so this is how it goes. So case 1 is, this equation can be written like this. So I got 175. Since all the values are known, I have put sigma B as 70. So 175. And in case 2, see, I have found out brass, stress on brass rod, which has come since sigma S is known. So what I have done, first I have put 70 here, brass value, and I got steel ka value as 175. And in the second case, I have put 120 steel ka value, and I got sigma B is equal to 48. Now the main concern here is sigma S was coming out to be 175, which is not safe because this is greater than the given value. The given value of steel, stress in steel was 120. In the question it is given as 120. So this is exceeding 120. 175 is more. That's why this is not safe, I have written. And when sigma B has to be found out, 120 I have put stress of steel here. So sigma B value was 48, but the given was 70 megapascal, 70. But the answer which I got is 48, which is less than 70. So this is acceptable, this is not acceptable. So my new values of sigma S and sigma B were coming out to be 120 and 48. Earlier it was in the given problem 120 and 70. But these are not fulfilling the design criteria, or the design is not safe. That's why I have taken these two values. Now we have to proceed with these two values. Now we know this formula P, earlier we have seen equation number 1, P is equal to sigma S. This is nothing but this is PS plus PB. So instead of sigma S I have put 120, instead of sigma B I have put 48. Areas, respective areas of the material can be found out by the usual formulas. So the total load which the bar can carry is coming out to be 89.57 kilonewton. So this one part is done. It means this composite bar can carry a load of, total load of 89.57. And delta L, then we have to find the change in length of the composite bar. So this is the basic formula from Hooke's law. So it can be found out in two ways. Delta L is equal to PS. Taking all the values of steel, I got 0.3, and taking all the values of brass, I got 0.3. Why it is coming same from both the cases? Because the material is composite, securely fixed from both the ends. That's why, and it is a problem of equal length. That's why the delta L is coming out to be 0.3 for both the cases. So this is a 10-mark problem, you can say, for the university, and hope you understood the concept of stresses in composite structure of equal length. Thank you for watching. Do like and subscribe my video. Thank you.